And how you doing today? All right. So hopefully you're super excited about graphing linear systems equations. So really the work that we've done in the past two lessons was really to set us up for what we are going to do today. All right. So it's going to involve a couple different things. So one, you can still going to be able to identify and verify a solution. All right. And now today we're actually going to solve the system of linear equations by graphing them. All right. So just to get you thinking again, right, for the opener here. All right. I want you to pause the video, and if you graph two lines, what could those graphs look like, right? What could those systems look like? What type of solutions could you get? So pause the video, draw a couple of examples, flip it back on, and let's see how that compares to what I will do as well. All right, so, a couple different things. So if I draw two lines, right, I could draw them to where they intersect once. I could draw two lines that don't intersect at all. All right, and then I could draw two lines, right, that are the same line. I could just draw that second line right over the top of the first line, right? And the idea behind this was just to get you thinking that there are really three outcomes that could happen, all right, when we're graphing two lines, right? We could have one solution, we could have no solutions, and we could have infinitely many solutions, right? So it's very, very good for you to understand that and know what to expect. All right, because if you know what to expect, that helps you self-check your work, all right, as you progress through it. All right, so now let's just go ahead and look at some visual examples, all right, with graphs already completed for us. So when you look at number one, all right, what is the solution to that graph, all right, or to, it really should say to each system, right? So what's the solution to each system, right? So if I look right here, here's where they intersect, and that is the solution. So 1, 1. All right, looking at number 2 here, right? Where do those two lines intersect? They intersect right here, and that is at 1, 2, 3, negative 4, 1, 2, 3, positive 3. So negative 4, 3 is that solution. All right, now when we look at number 3 here, notice we have parallel lines, right? We did some work, right, in our prior unit with parallel lines that was also to help us when we get to this point, right? We know that parallel lines do not intersect. If they do not intersect, that means there's no solution, all right? And so that's our answer. Don't leave it blank, right? So sometimes for some reason students think no solution, they just leave it blank. So write no solution. Now, once again, there are two lines here, right? Because this is a system. So if I only see one line, all right, if it looks like one line or it looks like one graph and I know it's a system, what that means is they've been drawn on top of each other. And that would mean that we have infinitely many solutions. All right, so once again, just another visual on what are the things that I should expect when I graph my lines. So speaking of graphing your lines, let's flip the page and let's look at some examples, right? And once again, this is good news because it's all review. So there's nothing new, right, to show you now. All we're doing is taking concepts that you should be familiar with, that you should feel comfortable with, right? And now we're going to work with them all together. So for example, number 5 here. We want to graph these two lines, and once again, I know they're both lines, no exponents, no absolute value bars. All right, and we want to see what type of solution I have. So if I look at my first equation, right, this is in slope-intercept form. My starting point is 0, 6, and my slope is negative 1 over 1. So I'm going to start at 0, 6, down 1 to the right 1, down 1 to the right 1. Now I'm going to probably go a few more points than normal, and I might even reverse it just because, remember, we're looking for points of intersection, and we don't necessarily know where those are going to occur. So I might go 5 or 6 points instead of our normal 3 points, all right, to help myself find those points of intersection. All right, and there's our line. Now, this is in point slope form. So I look at this, my starting point is 3, 3, and my slope is 1/3. So I'm going to start at 3, 3, and what do you know? All right, I can see that that point is already on the line I just drew. I'm still going to finish my graph, right? So up 1 to the right 3, 1, 2, 3. I'm going to reverse it, down 1 to the back 1, 2, 3 to the left 3. All right, and so we still want you to graph each line fully, even if you already know or see what that point of intersection would be, because we are also, all right, assessing your knowledge of graphing when you do these problems. So you can see now we're in that situation, right? I have one point of intersection. All right, and that point of intersection is 3, 3. All right. Okay, and that's all you have to do, right? So these really should be about like 2 to 3 minute problems, right? So a minute to graph the first line, a minute to graph the second line, and then maybe a minute to find and write what that solution would be. All right, so moving to number 6. All right, so once again, I can look at both equations here. I know they're both lines. There's no exponents, no absolute value bars. All right, so now start recognizing forms. So once again, this is slope-intercept form, okay? All right, my starting point would be 0, 2. All right, my slope is 3 over 1. So I'm going to start at 0, 2. I'm going to go up 1, 2, 3 to the right one, up 1, 2, 3 to the right one. And like I said, I'm just going to reverse that a time or two. 1, 2, 3 to the left one, down 1, 2, 3 to the left one. All right, generate a few more points as we don't know necessarily where these lines are going to intersect. And then draw my first line in. Okay, now if we look at line number 2, this is what we just spent the entire last lesson on, right? So very, very important that you have that recognition, because the recognition is going to lead to the method of graphing. So when I look at this, this is in standard form. My x and my y's are on the same side. So I want to find my x-intercept and my y-intercept, all right, and then graph those 2 points. Now, once again, right, I know every x-intercept is something y, every y-intercept is something 0 something. So negative 4x minus 2 times 0 is equal to negative 4. So negative 4x is equal to negative 4. Now negative 4 times what is negative 4? And that would be positive 1. All right, so my x-intercept is 1, 0. Now let's repeat that and solve for our y-intercept. So negative 4 times 0 minus 2y equals negative 4. That is all 0. That leaves me negative 2y equals negative 4. And then negative 2 times what is negative 4? Negative 2 times 2 is negative 4. So my y-intercept is 0, 2. And notice what happens. Once again, my x-intercept is 1, 0. My y-intercept is 0, 2, a point I had already graphed. All right. So there you go. And I can see by drawing my line through those 2 points. All right, that the point of intersection is 0, 2, and that would be my solution. All right, so jumping down to number 7 here. All right, now once again, this is recognition. This is the hard part for most of you. You have to recognize certain forms. And there are 5 different forms, right, of your line that you have to remember, right? So we've seen 3 of them: slope-intercept form, point-slope form, standard form. The next 2 forms are in this problem. So I have x equals 4. So what I want to do is just generate points where x is 4. So I'm going to write 2 points. So I'm going to do 4, 1, and I'm going to do 4, 4, right? So it says x has to be 4. So I'm just going to write 2 points where x is 4. So 4, 1, 4, 4. And what I can see is that is a vertical line. So x has to be 4 for every point on that line. And the only way for that to happen, all right, is to have a vertical line, right? So 4, 0, 4, negative 1, 4, negative 2, right? So if you get confused, just generate 2 points. And we've talked about it. You just need 2 points to graph your line. So notice y equals negative 2. All right, so I'm going to do 1, negative 2, and I'll do 3, negative 2. All right, so y has to be negative 2. It doesn't matter what x is, right? Y is negative 2. So 1, negative 2 would be here. 3, negative 2 would be here. And now you can see that that has to be a horizontal line. All right, so don't let the form confuse you. All right, help yourself by giving, all right, and writing your 2 points down, right? And then follow the directions from the 2 points, right? So if y has to be negative 2, create 2 points where y is negative 2. All right, and you can see that we get a single point of intersection here, and that point would be 4, negative 2. All right, and these lines also happen to be perpendicular. Little review from last unit. All right, one more to do together. Here, let's do number 8. All right, and when we look at number 8, once again, I know they're both linear, no exponential, or excuse me, no exponents, and no absolute value bars, and they are both in standard form, which means I need to find the x and y intercept for my first equation, and then my x and y intercept for my second equation. So if I'm looking for my x-intercept, I know y is 0. I'm going to plug that in. All right. And so 2 times 0 is 0. So I get 4x is equal to 8. Now 4 times what is 8? And that would be 2. So my x-intercept is 2, 0. Now let's find the y-intercept. And if I'm looking for the y-intercept, I know x has to be 0. And I get that. 4 times 0 is 0. That leaves me 2y is equal to 8. Well, 2 times what is 8? And that would be 4. So my y-intercept is 0, 4. So 0, 4 is right here. 2, 0 is right there. So let's just draw that line real quick. All right, so there's our first line. All right, now let's jump to our second equation here. So I'm just going to repeat that process. All right, so 8, all right, x plus 4 times 0 is equal to 16. 4 times 0 is 0. That means 8x is equal to 16. 8 times what is 16? And that would be x is equal to 2. Uh-oh. What do you notice right away? We've already got one common point, right? But don't assume, right? Finish the process, all right? And you'll see why as we do this. So now let's find our y-intercept. So 8 times 0 plus 4y is equal to 16. 8 times 0 is 0. 4y is equal to 16. All right, 4 times what is 16? And that would be y is equal to 4. And we get a y-intercept of 0, 4. So notice we get the exact same x and y intercepts, which means we're dealing with the exact same line. So this is a case where I draw the line the first time. I would just draw this line over it the second time. All right, and then when that happens, we know that is an infinitely many solution problem. All right, so that wraps up our lesson on solving systems of linear equations graphically. Once again, you have any questions, something that makes sense, highlight that question, circle it. All right, bring those questions into class. We'll clarify before we move on to the next piece. See you then.